My name is Drew Bonheyo. I'm a freshman at the University of Minnesota. My major is electrical engineering. This is for class EE 1301 with Professor Faisal Kaleem. The project I created was a light-controlled fire LED display. Quick description of the project is basically when I turn off the lights or when it's uses as a light sensor to sense the brightness of the room. And when it's dark enough, the LEDs will display a fire effect. LEDs they're used in a lot of places. Programming LEDs are used for special effects in movies and plays. A lot of lighting is used in those applications. And more everyday uses of programming LEDs include stoplights, railroad crossings, cop cars and ambulance cars, the lights on top. First, I'm going to show the demo of the project, and then I'm going to go through the hardware, assembly, and finally the code of the project.
Okay, now we're going to move on to the demo portion. Okay, so right now the code has already been uploaded on the Arduino, and a quick description of how this works. Once again, this light sensor right there, right there, that will be able to sense the amount of light in the room basically, and it will give it a value, and when the value is low enough, it will denote that the room is brighter, and it will not turn on the LEDs. As you can see, they're not on now because the lights are on. But when, as I will show in a minute, when the lights are turned off, the sensor will be able to tell that and will send that to Arduino, which will then flash the LED fire display. And I'll show that demonstration now. Turn off the lights. As you can see, this is the fire display right here, and this loop will run forever and it will never terminate, even when the lights are on or off. And I'll turn the lights back on again to show you that the fire display will terminate. Oh, whoopsies. And when the lights are back on, you can see that this is the LED fire display ends, and I'll turn them back off again, I guess. And yeah, that's basically how it works. Okay, and now the next part of the video, I'm going to go through the hardware aspect.
This slide displays a list of all the hardware used for the LED fire display effect project. You can see the LEDs were used to display the light. And then jumper wires are used to control where the current goes on the breadboard. And 650 ohm resistors were used to, resistors are used to limit the amount of current that is passing through. And so the resistors would limit the amount of current going to the LEDs and the light sensors so they wouldn't fry and break and be unusable. I've definitely had experience frying some LEDs. And then the light sensor, pretty straightforward, used to sense the lights. Breadboard. The breadboard is basically the base that allows for construction. As in construction, it allows for how you place the jumper wires, the LEDs, and the resistors, and with any project, and how you arrange it. The Arduino Uno, obviously, this project wouldn't be possible with it. It provides a voltage. The code is run through it. Yeah. And then the USB cable is used to upload the code from the computer on the Arduino. Next, I'm going to show a circuit diagram of how the project worked. Now I'm going to draw out the circuit for the LED fire display project. Okay, first I'm going to start out with how the light sensor works. So basically what happens is
5 volts is going to come from Arduino, which is then going to go through a series of 3 150 ohm resistors, which then will reach the light sensor. Okay, so then these are all 150 ohms, and because they're all in series as shown in the diagram, you can add their resistances together. So basically this is just one 450 ohm resistor. And so after the currents pass through the resistor, it's going to go to the sensor, which will then allow the sensor to be able to read the light values in the room. And once it has gone through that, it will go to ground. And then the current flowing through this is simply just I equals V over R, which is 5 over 450, which equals 1 over 90 amps. So this is part of it, and now I'm going to run through quickly how it works with the LEDs. It's pretty similar, not really too much different in any ways. Same process happens. 5 volts is going to come from Arduino, and then instead of going through a series of 3 resistors, it's just going to go through one 150 ohm resistor. And then after it's passed through the resistor, it will reach the light, or the LED, which will either turn on or not turn on the light, depending on the light, what the value of the light sensor. And after it is passed through the LED, this will go to ground. And the current flowing through here is once again I equals V over R equals 5 over 150, which is 1 over 30 amps. Okay, pretty straightforward. Now we're going to move on to the assembly part. Okay, so now we are moved on to the assembly part. As you can see, we have a breadboard, we have Arduino Uno, jumper wires, light sensor and LEDs, and then 6 150 ohm resistors. If you can see, the color combination is brown, green, brown. Okay, so now we'll start out with the light sensor. Light sensor requires voltage, so we will hook that up to the 5 volts on Arduino and put this into the red positive sign row. This row with the red on it next to my finger, that will all now have 5 volts on it, and the negative blue row just denotes ground. And voltage also on the breadboard will this way, if jumper wire is attached here, or it will be consistent through the rows. Okay, so now we'll use another jumper wire to transfer the voltage to the actual breadboard, like so. And now it's got to go through these 3 150 ohm resistors, and once again these resistors are in series, and sometimes they can be really painful to try and get in, like they are now. Okay, yeah, so these are all in series, and we'll have an equivalent resistance of 450 ohms, as I mentioned earlier. And this will be delivered to the light sensor, just about down here. Okay, and then since the Arduino will be reading from the light sensor, we will need to use one of the analog in pins, and so we will use a 0 so it can receive readings from the light sensor, as we can see here, which will then, after the voltages pass through the light sensor, this will just go to ground, and we'll have ground be on the other side. Like so. Okay, so that part was pretty simple, pretty straightforward. Now we're gonna move on to the LED part. So the LEDs are a little bit different, as they have to use the PWM pins, which are, if you can see, there's little dashes next to them. And what these PWM pins allow the LEDs to do is they can control the brightness of the LEDs. Okay, so we're going to use pins 9, 10, and 11 because they are PWM pins. And I'll hook this up now. And it's going to come, so it's going to come through the pin, and then it's going to go through a 150 ohm resistor, which will then go to one of the LEDs, which will go to ground after. Okay, so here's first LED, alongside first, and then after this will just go to ground. Okay, and the exact same setup for the next two LEDs. While you guys are waiting for me to finish this, I don't know, have a little comic relief for you. Two antennas got married. I heard the wedding was terrible, but the reception was phenomenal. A little comic relief. Okay, just about done here. Okay, then this will go to the pin, and this will lastly go to ground. Okay, so this concludes the assembly. Not too difficult, pretty straightforward, as you can see. And now we're going to talk about the code and how the hardware and the software work together to form this project.
Now we're on to the last part, which is just a breakdown of the code and kind of how the hardware and the software fit together through the actual programming. Okay, and I broke it down into 3 parts. There's the preprocessor commands, there's the void setup, and the void loop. This slide here is the preprocessor commands, which are first done before any action is completed on the Arduino. And the first line, the hashtag includes studio.h, includes the standard library of functions that were used in this project. And if you're wondering what these backslashes are, or what they are, or they're just comments, and it's commenting out the code, and they don't actually have any input in the function. All it does is just make your program more readable so people actually understand what it is that your code is saying. The next 4 lines, they just declare the pinouts for the LED and the light sensor. The 9, 10, 11 were the PWM pins that I mentioned earlier. The last line I created a variable of type integer. It's an integer variable that's called light value, which is, I created this light value, which is what the light sensor reads, and I stored it to that variable, as you'll see later in the loop, and I just initialized it to 0. So that's just, and I put it in the preprocessor commands because I used it throughout, I used it in multiple scopes, so I figured it would be the easiest to use. I put it in the preprocessor commands. Now we're going to look at the void setup. Okay, this is the setup. Really, it's pretty straightforward. Not a whole lot is actually going on in this part of the code. But the first line, the serial.begin 9600, is this project. I had to use the serial monitor, and all it does is it basically initializes the monitor to a certain speed which it's reading from Arduino. And 9600 baud is just, it's a pretty standard speed. And then the next 4 lines, the pin mode, just declares that the LDR pin, which is the light sensor pin,
is the input, so it will be receiving values from the light sensor, which will be transferred to Arduino, and that the pins for the LEDs are the output, and they're the PWM pins that used to vary the brightness of the LEDs, but the output depends on the input. That should make sense on the light sensor value, and we'll get more into that into the actual main part of the code, which is the loop, which is coming up next.
Yeah, sorry for the different camera angle. I just thought you guys would be able to see the code better. But let's run through it, because now we're in the loop part, which is the most important part of the code and where basically the magic happens. Anywho, so the first line reads analog read LDR pin, semicolon, equals light value. So what that is saying is earlier I created the light value and initialized it to 0 before the program had started running. But now the analog read LDR pin means that the Arduino will read a value between 0 and 1023, which denotes the brightness of the room. So 0 would mean like complete brightness, like very, very bright, and 1023 would mean very, very dark. And so it will send this reading to Arduino, and it's stored in the variable light value. Okay, and then the next line is the delay 100. What all that says is it will delay 100 milliseconds before it completes any action. The reason I put that 100 millisecond delay in was because usually the light sensor will get a more accurate reading. It has a little bit of a delay. And then the serial.print light value was used. What happens is it will print in the serial port the value read from the light sensor. Mainly it was used for, I used that command for myself so I could figure out the normal value between light and dark in a room. The serial print.%\n, all that means is that it will print the value and then return to the next line, print the next value. Okay, and then there's an if statement that says if light value is equal to or greater than 650. So if the light sensor reads a value greater than that, then the LED fire effect will take place. So the analog write LED pin, it will write these three to a random value between 120 and 255, and those are colors that are mainly associated between yellow, red, orange in there. But what's happening is as you can see, the next line is delay random every 75 milliseconds. It will pick a new random color value between those ranges, which will give the effect, the visual effect of like an LED fire display. And then if the light value does not happen to be greater than 650, then it will just keep printing off the light values, which are smaller. And so technically this loop will never terminate and will consistently be running. That's the end of the project explanation. The last part of the video is class requirement. Feel free to keep watching.
Class has been very helpful to take, to be honest with you. I came in there not knowing really anything about coding. I knew I wanted to be an electrical engineer. Like I've worked with hardware stuff, but this class taught me a lot. One, I learned a lot about programming, and also when I learned about programming, I learned that I didn't really like programming itself that much. I liked working with the hardware a lot more, working with the hardware aspect on like the group project, and the individual videos are fun. And the group, and like, I guess working the software and hardware together to make projects is also enjoyable. just programming itself, I do not find that enjoyable, and that's one thing that I learned from this class. Also, I learned from this class, my future aspirations are they're definitely on the hardware side of it. I'm not exactly sure which discipline I still want to go into yet, but something maybe with audio or sound or something like that sounds very interesting. There's a lot of different options you can take in electrical engineering, and I'm glad I took this class because it showed me where my interests actually are. And I'd like to thank you, Professor Kaleem, for a great semester.